Hi everyone, this is student innovator Cantrell here at UCLA with a little bit of a fun neural network demonstration. Um, as you get bigger and bigger graphics cards, you can do some interesting projects. This is a publication from a little over 2 months ago by a team from NVIDIA. Title of the paper was Progressive Growing of GANs for Improved Quality, Stability, and Variation. Um, this NVIDIA URL has pretty much everything, including some cool videos. The actual archive links here. Paper's pretty interesting, primarily because GANs trained on the Celeb A dataset have historically struggled to achieve large resolutions, and they've managed to pull that off here. So, very interesting paper, but more importantly, it just outputs really cool images. So, quick demo of what it looks like is available here on YouTube. And they've got 1 hour of imaginary celebrities. What you're seeing here is them interpolating across a latent space that the generator network uses to output these really high resolution facial images. These people are all synthetic images that have been trained to fool a neural network, convince the neural network they're human faces, and using a high powered GPU, you can actually run this on your own computer. So, without any further ado, one person was nice enough on Reddit to actually upload some code to GitHub where he's copied the weights over to allow you to use PyTorch. I found this GitHub repo to be a little bit easier to use than the one from NVIDIA. So it was the one I went after for modification to suit my needs. This repo doesn't actually have the ability to train, so another guy claims this repo works for that as well. I haven't actually tried using it yet, but maybe in a following video, I'll go ahead and show that. This video is really just a demonstration right now of what this looks like running on your PC. So let's get started. So what I ended up doing is I modified this quite a bit in order to allow me to generate new randomized vectors, plug them into the model, and then the model will output the image. And most of this code is just helper code to help me do a little bit of a random walk across the high dimensional vector. It's a 1 by 512 array that you feed in to the neural network, and then it outputs the image. So this code just shows what dimensions are currently being modified, the difference between the old location and then the resulting value. I think I'm using a uniform random number generator to actually make these, and then I'm also selecting the dimensions at random too. So let's go ahead and run it and see what happens. Now, without a GPU, you can probably run this, but CUDA GPU gets you more frame rate to where you can actually kind of enjoy the effect that comes out. Takes a second to load the model weights into the GPU, but once they're loaded, you start getting decent frame rates. Originally, this code actually used matplotlib to try and display the images. For whatever reason, I was having issues with that on my PC, so I went ahead and modified that to use OpenCV's I am write feature and just writing to a .png file in the file system. Fortunately, the default image viewer that comes with Ubuntu will automatically refresh as the image you're viewing is updated. So just by doing multiple writes with I am write, you end up getting the same benefit as if, yeah, there we go. All right, now you just sit back and watch the show. It's kind of interesting. I'm jumping to a new location once every 50 frames, and I'm doing, I think, 5 frames for any specific set of 4 dimensions. I'm not isolating the dimensions I'm modifying 4 at a time just to get a little bit more variation. Otherwise, the images would look a lot more static. I haven't read the paper in great detail to know this for sure. It's interesting to what degree something like glasses or hair length vector are orthogonal to the other vectors. I haven't actually looked into that, but it would be a really nice thing if you had that orthogonality, because then you could move a slider bar back and forth depending on how fast your GPU was, and get almost real-time modification of an image. Um, Neural network Photoshop essentially is kind of a cool concept. So this video is step one of an attempt to do something a little bit more creative as opposed to just running somebody else's code. And this glitch I'm having right here, list index out of range, not really sure where that's coming from. It seems to work quite fine, and then encounter an error. So I've just gone ahead and restarted the code. Speaking of which, one of the dependencies I ended up having to install was sudo apt-get install python 3-tk. So if you're having problems running this, there are only a couple dependencies I needed for this code. One of the things that made it a pretty pleasant experience getting it up and running. PyTorch, of course. There we go. See how the hair is actually blending into the glasses frame, kind of interesting. One of the fun things about jumping around is you also get to see the camera actually change perspective. Just for readability's sake, I went ahead and truncated or rounded the decimal places here to 2 decimals. But yeah, fun little demo. GitHub code will be in the YouTube description. And thanks for watching. I'll just leave this running for a couple more seconds. Couple of interesting ones. I've seen several examples where the human face doesn't have matching eye colors, which is kind of strange. Although right now I don't think that's the biggest problem with this image. Kind of illustrates that the image quality isn't uniform across all possible vectors.